If you're in the mood to nerd out with some tech talk, then stay with me as we take a dive into the deep end of the photographic pool. Hello and welcome to 5-Minute Photo. I'm Bill Ferris. In this video, we're going to get technical, talking about how we make images with digital cameras. And we'll talk about some specific terms including aperture, focal ratio, we'll talk about sensor size, and we'll begin at the beginning talking about focal length. Now, focal length is typically the first quality we talk about when discussing lenses. And one of the misconceptions that some folks have is that the focal length of a lens is measured from the lens opening at the front to the back of the lens. However, focal length is actually measured from the optical center of the lens to the image plane, to the sensor where that image is formed. And as we take a look at this diagram of a 50mm lens, we can see that the optical center is actually in the middle of the lens. And the image plane, the sensor, is behind the lens. So focal length is measured from that optical center, typically somewhere in the middle of the lens, to the sensor, the image plane, behind the lens where the image is formed. And focal length determines the magnification of the image on the sensor. We talk about magnification as an angle of view. How much of the scene is the lens showing us that we're framing? A 50mm lens delivers about a 47-degree angle of view, and because this closely matches our normal human vision, that 50mm lens is often described as a normal lens. As focal length gets shorter, magnification is reduced and the angle of view increases. So a 24mm lens delivers a much wider angle of view and lower magnification than that 50mm lens. By contrast, a 200mm lens delivers a much more narrow angle of view and higher magnification. The subject looks larger in our image. As we take a look at this diagram, comparing the sizes of sensors that we use in digital cameras, we're going to talk about the effect that sensor size has on that angle of view of the image that is being recorded at the camera. Now, as you can see, a full-frame sensor in a modern digital camera has a sensor that's about 36mm along its longest size. An APS-C camera, such as the Nikon D90, has a smaller sensor. It measures about 24mm on its longest size. And probably the most used camera in society today, that smartphone camera, has a sensor that might be only about 10mm along its longest side. So I have a couple of high-tech visual aids for you here. The blue card represents the size of a full-frame digital camera sensor, and this red card represents the size of an APS-C camera sensor. And as you can see when we overlay the two, obviously the APS-C camera sensor is smaller. So let's talk about how that affects the image that we're able to make with our cameras. Well, right off the bat, one of the things that you'll notice is that this smaller sensor is collecting a smaller portion of the cone of light that's delivered by the lens to the sensor in the camera. And so that's why APS-C and smaller sensors are referred to as crop sensors. They literally crop a portion of the image that's delivered by the lens. And so for this reason, the angle of view that a crop sensor camera body records is generally narrower than the angle of view than is recorded by a full frame camera body or a camera using a larger sensor and a lens of the same focal length. So for example, that 50mm lens, which delivers a 47-degree angle of view with a full frame camera body, delivers an angle of view that's about 1/3 narrower. And so higher magnification, the subject looks larger in the image because that smaller sensor is cropping the image. As we take a look at another diagram, we're going to talk about another effect that sensor size has on the image we're recording with our digital camera, and that is depth of field. Now, depth of field can be thought of as a range of distances within the image that appear acceptably sharp or in focus to your eye. And looking at the diagram, we can see illustrated a shallow depth of field image where a narrow range of distances appears to be in focus, And the second illustration is a deep depth of field or a wide depth of field where a wider range of distances within the scene appears in focus on the image we're making with the camera. So let's talk about the effect that sensor size has on the depth of field we record in an image. Now, a full-frame sensor camera body will record an image with a certain depth of field, a certain range of distances within that image that appear in focus. But using a crop sensor camera, that depth of field will increase. A greater range of distances will appear in focus. And this brings us to a term to discuss called focal ratio. Focal ratio describes the relationship between the focal length of the lens and the aperture of the lens. And we know that focal length is that distance from the optical center to the sensor, the image plane where that image is formed. Aperture is simply the diameter of the opening that allows light to enter the lens. Now, as focal ratio decreases, as the focal ratio number, that f number, becomes smaller, depth of field also becomes smaller. It becomes more narrow. A shallower depth of field is recorded in the image. As focal ratio increases, as that f number gets larger, then depth of field also increases. A wider or deeper range of distances in the image appear in focus. And to illustrate this, let's take a look at two images that I shot with my Nikon D610. So the two main effects that shooting with a crop sensor body can have on the image we're able to make with a full-frame sensor camera by comparison are that the smaller sensor will crop a portion of the image that's being formed by the lens, and also the depth of field will be deeper, will be wider. But we can compensate for this, and this next diagram illustrates that. In this we have four images. Two images were made using my full-frame Nikon D610, and two were made with the DX format Nikon D90, a crop sensor camera body. All four images were made using the Tamron 70 to 200 millimeter lens. So let's look at the first two images. The Nikon D610 and the D90 are both being used at f4 with that Tamron lens. The D610 is shooting at a 105 millimeter focal length, the D90 at 70 millimeter focal length. So you'll see that because of the cropping effect of that smaller sensor in the D90, both images record approximately the same angle of view. So that's one way we can compensate for using a camera with a smaller sensor, is to shoot at a shorter focal length to match the angle of view delivered by a larger sensor camera shooting at a longer focal length. Now, you'll notice that comparing those top two images, that the D90's depth of field is actually a bit wider. It's not as shallow, not as narrow. So by closing the focal ratio down to f2.8 from f4, we compensate for that. So in the second two images, the D610 and the D90, the D610 at 105 millimeters f4, the D90 at 70 millimeters f2.8 are recording approximately the same angle of view and depth of field. And so this illustrates how we're able to compensate for shooting with that crop sensor camera body when doing photography. So as we take another look at that illustration showing the relative sizes of sensors that are used in today's digital cameras, let's talk about the role that sensor size plays in the exposure time needed to make an image. And for some of you, I think you'll find that the outcome of this discussion will be a bit surprising. Now, looking at the comparative sizes of a full-frame sensor and a crop sensor, you might think that because the crop sensor records less light, there's less surface area upon which the light will fall, that the crop sensor camera would need to make a longer exposure in order to record the same total volume or quantity of light and make a properly exposed image. In fact, that's not the case. And that's because it's not the total volume, it's not the total quantity of light the camera records that determines a properly exposed image. In fact, it is the brightness of the image, the intensity of that image across the sensor. And to better understand this, we need to go back to that term focal ratio, because focal ratio determines the length of the exposure that's needed to make a properly exposed image with a digital camera. And to understand this, or to see this in action, let's take a look at images made with my Nikon D610 and D90 cameras. Again, the D610 is a full frame camera, the D90 a crop sensor body. Now you'll see, looking at these images, that they were all made with the same Tamron 70 to 200 millimeter zoom lens, and that in the sets of images, both cameras were operating at the same focal length and the same focal ratio, and used the same length exposures to make their images. So despite the fact that this crop sensor D90 was recording a lower total volume or quantity of light than the full frame D610, it was still making a properly exposed image because those exposure lengths produced images with equivalent brightness across both sensors. To get a better understanding of this, or to look at this in a different way, here's another illustration. This one's showing a sensor inside a digital camera, and you can see I'm illustrating the amount of light it's collecting by a depth of light that's falling on that sensor, that depth of light representing the average brightness or intensity of the image across the sensor. Now, if we overlay a crop sensor in this illustration, we can see that the crop sensor, being smaller, will record a lower total quantity of light, but the intensity of that image, the average brightness of the image across the crop sensor, is exactly the same as the average intensity of the image on that full frame sensor. And so this is how cameras are able to make and record properly exposed images. It's determined by focal ratio, which determines the average intensity of the image on that sensor. Here's another illustration. Let's go high tech with two measuring cups filled with water. They both have the same volume or quantity of water. One cup in here, one cup in here. Now this represents that larger full frame sensor camera. This represents a crop sensor camera. Now you can see that the depth of the water in the two cups is different. There's a shallower depth, a lower intensity of light on the full frame sensor here, and a greater depth, greater intensity of light on the crop sensor here. So we don't need all this light. We pour out some of the light, and now both sensors are collecting light to the same intensity, the same depth. Both are making properly exposed images using the same length exposure at the same focal ratio. Here's another way we can illustrate this. Here's another set of images comparing the performance of full frame and crop sensor camera bodies. In the first column are images made with the Nikon D90, and in the next three columns are images made of the same subject and using the same lens, but with the Nikon D610. Now for the Nikon D90, the images were all made at f2.8, but at different focal lengths within the zoom range of that Tamron 70 to 200 lens, at 70 millimeters, at 100 millimeters, and 135 millimeters with the D90. In the series of D610 images, we have exposures that were made at the same focal length and focal ratio as the Nikon D90. The second set of images, that middle column, show images where the focal length of the lens used was adjusted so that the D610 would record approximately the same angle of view as the D90. So instead of 70, 100, and 135, it is 105, about 150, and 200 millimeter focal length. And the final set of images were with the focal ratio of the D610 adjusted so that the depth of field recorded in the images of the D610 would be comparable to that of the Nikon D90. And you'll notice that only when we close down the aperture of the D610 to increase the focal ratio do we get a significant difference in the length of exposures needed to make a good image with the D610. So the next time you're in a conversation with a photographer about how to make good images with your camera, and the subject of aperture comes up, yes, aperture is important. That does control the light, the amount of light that's able to enter your lens and fall on the sensor. But keep in mind, it is the focal ratio, that F number, that determines the length of the exposure that's needed to make a good image with your camera. That's what's key, that focal ratio. Not only does it control your depth of field, but it controls the length of the exposure. And regardless of the type of camera that you're shooting with, be it a full frame camera, a crop sensor, APS-C camera, or even something with as small a sensor as your smartphone. Keep in mind that there are steps you can take to compensate for the differences in performance of those smaller sensors. You can reduce the focal length to record a wider angle of view to match the angle of view you're getting with a larger sensor camera, and you can shoot at a smaller focal ratio. You can increase the aperture to reduce the focal ratio to make more shallow your depth of field. Well, there you have it. Let's get out of the pool and let's dry off. Thank you for joining me for this conversation about how we make pictures with digital cameras. I'm Bill Ferris, and I'll see you next time on 5 Minute Photo.